In this tutorial, we will be discussing amines. Amines are derivatives of ammonia, NH3, which looks like this. It has a lone pair and 3 hydrogens coming off of it. One or more of these hydrogen atoms are replaced with alkyl or aromatic groups. They contain nitrogen attached to one or more alkyl or aromatic groups. So here is our nitrogen. It has 3 alkyl groups coming off of it. Here's this nitrogen. It has 2 alkyl groups on it. And this one just has 1 aromatic. You can classify the amines just as you would to classify the alcohols with primary, secondary, or tertiary. And it all depends on how many alkyl groups that are coming off of it. For instance, here, there's only 1 alkyl group, and that's the methyl group. So therefore, it's primary. Here, there are 2 alkyl groups, which would make it secondary. And finally, there's 3 alkyl groups, which would be tertiary. And here, if you prefer the stickball method, where you can actually see the models written out. Simple amines are named as alkyl amines. They list the names of the alkyl groups bonded to the nitrogen atom in alphabetical order in front of the word amine. Notice that it's alphabetical. And when we talk about alphabetical, if you don't remember, things like this where there's a di in there for methyl, that di is not considered part of the alphabet alphabetizing it. Use prefixes to identify duplicates. So here, this is an ethyl group, so it's ethylamine. Here we have 1 carbon here and 1 carbon here, so we have 2 methyl groups, so it's dimethylamine. And then finally we have an ethyl group and 2 methyls, so they do ethyl dimethylamine. So what's the common name of this, and is it primary, secondary, or tertiary? Well, here's the nitrogen. There's only 1 carbon group coming off of it, so it's primary. The 1 carbon group is actually a propyl group, so it would be propyl amine. Here's another one. There's 3 carbon groups coming off of it, so it would be tertiary. We have an ethyl group, a methyl group, and another methyl group. Alphabetically, we put ethyl before methyl, so ethyl dimethylamine. The amine of a benzene is called aniline. This one is N-methylaniline, because on the nitrogen is a methyl group. This one here is wrong. Please note that in your notes. There should be an H here for the aniline. But N stands for nitrogen, and that means something's coming off of the nitrogen. Here, when it's coming right off the benzene ring, they tell you what number it is. So this chlorine here is on the 3rd carbon. 1, 2, 3. You start at the nitrogen. So 3-chloroaniline, because this portion right here is aniline. Give the common name of each amine compound. We have an ethyl group, a methyl group, and another ethyl. Ethyl comes before methyl alphabetically, so it's diethyl, methyl, amine. Here we have the aniline group, and this is ethyl. So I put an N in front of that to tell people that it's coming off the nitrogen. So N-ethyl aniline. Right there. Now, skeletal structures are just like the other kind of skeletal structures. At the end of this line, since the nitrogen is there, that's what it's bonded to, so there's no carbon there at the end of this line. But there's a carbon here, here, and here. So propylamine, there's 1, 2, 3 carbons here, therefore it's propyl. This is an ethyl group. This is a propyl group. So ethyl propylamine, ethyl, ethyl, methyl, diethylamine. Primary and secondary amines with fewer than 6 carbons are soluble in water. Thus, they can form hydrogen bonds with the water molecules. So here we go. This has more than 6 carbons, so it is not soluble in water. It's just too nonpolar. So if we look here, this one has 3 carbons, so this one's soluble. This one has 2 and 1 more, so that's 3. That's soluble. There's no nitrogens here. It's a trick question. That one's not soluble. Ammonia, as well as primary and secondary amines, act as Bronsted-Lowry base because an alone electron pair on the nitrogen accepts hydrogen from water to produce an ammonium ion and a hydroxide ion. So here's ammonia. Remember, there was a lone pair here. It'll take one of these hydrogens to do ammonium. Well, there's still a lone pair here, so it'll take one of those hydrogens to form the methyl ammonium ion. An amine salt forms when amines such as those responsible for the odor in fish are neutralized by an acid. Amines react as Bronsted-Lowry bases in a neutralization reaction with citric acid. So here we have a methylamine. If we react it with an acid, such as HCl, we end up forming a salt. Remember, generically, the word salt is any ionic compound, so we'll have a positive and a negative there. So here's our positive, and here's the negative. This lone pair of electrons comes over and takes the hydrogen, so it goes from NH2 to NH3, and then that Cl minus is the negative portion of that salt. So methyl ammonium chloride. This one would then be dimethyl ammonium chloride. Amines are usually converted to their ammonium salt before being used as drugs. The ammonium salts are solids at room temperature, odorless, and soluble in water and body fluids. Heterocyclic amines consist of 5 or 6 atoms in a ring with 1 or more nitrogen atoms embedded in it. So write the structural formula for methylpropylamine. So we have nitrogen here because it's an amine. We have 1 methyl group. We have 1 propyl group, 1, 2, 3 carbons, and then we have a hydrogen coming off of it. Write the structural formula of 2-chloroaniline. So you might remember aniline is NH2 with the aromatic group, a benzene group coming off of it. Remember that 2 there means it's off the benzene ring itself. If it said N, it would be coming off of the nitrogen. And that's your overview of amines.